Hey all, welcome to ShareTreck. This is Raj here, and this is the Sunday edit. Good morning to you all, and I hope you have a great weekend. We talk about genomics daily in this channel. Today, in this three-part series, first I'm going to talk about some of the most amazing things I have come across in genomics during the last 9 months since I started this channel. In part 2 and 3 of this limited series, I'm going to talk to you about two other fields that are progressing in the same spirit. I'd like to give credit to our subscriber Ishkadesh for bringing one such development to my notice. If you're curious, let's get started. Hey all, welcome back. First, I want to talk about what I find really amazing regarding how we as a species have progressed and made the world a better place. And in the process, I want to touch not only on genomics, but also on two new technologies that have caught my attention and seem to be getting greater visibility in the media. The first one is genomics, and the other two are in space launch technology and data management area. It's amazing how in our earlier industrial revolution, we tried to create machines to solve problems that took a lot of human efforts. Examples that come to mind are the bread dough making machines used in bakery or the food processing machines. We also tried to create machines that could provide the power of beast of burden we used earlier, and hence horse carriages became cars, and we now have tractors doing the work of animals in preparing the field for sowing crops. In all events, the approach was mechanical. However, we are now in a new era where our collective knowledge and experience is moving us towards more elegant and effective approaches to solve problems. The initial part of this enhancement came through integrated circuits and circuit boards and electronics incorporated along with mechanics, piezoelectronics and all that. But now we are entering into an even more refined era. Most in this community are already aware of how genomics and gene editing have helped address the root cause of disease against treating symptoms. Earlier, we used to check patients, identify the symptoms, and there was a medicine given for each of these symptoms. And essentially, doctors were treating symptoms in order to cure the disease. We have now got 3 approved gene therapies and more in the pipeline, where the philosophy is towards treating the root cause rather than the symptoms. So it's a much more enhanced, much more superior approach. Over and above CRISPR and Cas9 proteins, CAR-T therapy is also an amazing showcase of how tumors are being hunted and destroyed. Initial attempts at creating CAR-T therapies faced a lot of problems. The first problem was to evade the immune response and keep the CAR-T cell alive. Then came the fact that the engineered cells could not last long enough within the body. Each of these problems have been solved step by step, and we have come a long way. However, when you look at IMATIC's bispecifics called as TCER, that is T-cell recruiter, it's a very elegant solution that provides all the benefits of an allogenic approach while keeping the treatment as simple as possible by just adding an adapter that launches onto tumors on one end and recruits the nearest T-cell and gets the T-cell to release cytokines to kill the tumor cell. Let me just take you quickly to the website of IMATICS and just walk you through the process. You'll find that it is such a simple and elegant solution. I'm really excited about this approach because it's so elegant. This you can look at this TCER as an adapter. So on one end, you have a TCR domain, which would probably be an antigen that would be present on the cell that is being targeted. So tumor cells have different antigens depending on what type of cancer cell they are. And you can specify a particular antigen that's going to be anchored out here in the TCR domains. And in the T-cell recruiter out here, this is what attracts the nearest T cells and recruits it in order to release cytotoxic lytic granules and kill the tumor cell. So in theory, the way I look at it, I'm not a scientist, but as an investor, when I look at this schematic out here, I can see that the T cell recruiter can remain the same because the body has the same T cells, but the TCR domain can be changed. And by doing that, this as a platform, TCER as a platform, can be easily adapted to target different types of tumor cells. And again, this is an allogenic product because it can recruit the body's own T cell instead of taking a T cell out either from the patient and changing it and putting it back into the body to essentially perform the same function. So once we have a platform like this, I think it's going to be much easier to handle tumor cells. Now, I am now eagerly looking forward to how this progresses on the FDA approval processes. Imagine how easy it would be for this platform if they just have to change the tumor receptor and reuse the rest of the components. I suspect most companies will follow this approach going forward, and IMATIX may get good royalty. And the concept of autologous treatment might probably recede when it comes to cancers. But for other things like sickle cell anemia, I think we still have the allogenic versus autologous approach. As you can see, the qualitative improvement and elegance of solutions to problems have been improving steadily. I'm very hopeful that this problem-solving ability will be able to help us reverse many problems that we have created due to our ignorance in the early days of civilization. Take the example of plastics. It was considered a great innovation when plastics were introduced. You started having plastic buckets, plastic chairs, plastic doors, plastic everything. And the market was flooded with plastics before we recognized that it does not decompose and can cause a problem. Now we can engineer bacteria to decompose plastics because of our understanding of genetics, because of our understanding of genomics. I'm hopeful that we may come up with genetically engineered crops and trees to suck out carbon dioxide from the atmosphere in a much faster pace. Imagine if the crops can be engineered so that they take in 3 times as much of carbon dioxide or 2 times as much of carbon dioxide from the atmosphere. Given that we have so many of fields across the world, if all of them have crops which are genetically engineered to take out a lot of carbon dioxide, we can start making a dent on global warming, despite the fact that the oil companies will continue to pump oil and continue to resist alternative energy until the last drop of oil is taken off the earth and burned. As long as there is oil, the financial incentive to develop alternative energy will have to come from activists only, because governments are lobbied by oil companies, and genomics provides a hope here. So be proud of being a genomics investor, as you are supporting a good cause. That's how I would put it. And that's how I see myself when I invest every dollar that I have allocated for the genomics sector. This concludes part 1 of the video, because I want to keep it short. I mean, all of us have a limited attention span. Part 2 and part 3 will follow. Part 2 will talk about revolutionary space technology, and spoiler alert, it's not SpaceX. Part 3 will be around data storage management, and that's not Oracle or Microsoft that I'm talking about. So with that, I'd like to request you to put a like out there in case you like this video. And if you're not yet subscribed, why not? Please subscribe and help us grow this channel. You have been watching videos in this channel anyway, and you're here today watching this video. Just subscribe and help us grow this channel. Thanks and have a great day. Bye for now.